We're going to complete lesson 3.2. This is part 2, and we're going to be using the elimination method for solving systems of equations. So we have 4 steps that we're going to go through. Step 1, we're going to put both equations into standard form. And both equations into standard form is where we want like ax plus by equals c. Then we're going to multiply one or both equations to create opposites to eliminate one variable. So that's that eliminate term. We want to eliminate a variable when we're solving a system. Step 3 is to add the 2 equations together and solve. And to step 4 is to substitute what we get in step 3 into one of the equations and solve for the other unknown quantity. So pause the video, write down the steps, and then we'll do an example to show you how it works. Alright, so here we have a system of equations, and they're both already in standard form. So what we're going to do is we're going to take a look at both of the x terms and the y terms. And what we're looking for is opposites. So do you see we have a 4x and a negative 4x? Those are opposites, which means that when we add them together, we're going to add vertically, they're going to cancel out. And we want that to happen. We're eliminating, in this case, the x term. So if I take 4 plus negative 4x, those cancel. Continuing on down the line, 2y plus 3y is 5y. And that equals 9 plus 16, which is 25. Then we're going to finish solving. So I'm going to divide by 5. And we notice that y equals 5. So in our solution, the y-coordinate is 5. The last thing we need to do is to take our value of 5 and plug it into one of the original equations. So I'm just going to start with the first one. And I'm going to take that y equaling 5, and I'm going to plug it in for y. And then I'm going to solve. Subtract 10, and 4x equals negative 1. Divide by 4, and x equals negative 1/4. So the x-coordinate is negative 1/4, and we've solved the system. Alright, this second example is a little bit different because, as you can see, if we take a look at the x terms, 2x plus 3x is 5x, and they don't cancel. Also, if we look at the y terms, 7y and 5y adds up to 12y, and they also don't cancel. So what we're going to do is we're going to multiply both equations by something in order to create the situation where they do cancel. So first you're going to pick a variable. Do you want the x's or the y's to cancel? Well, I'm going to work with the x's. And since 2 and 3 both have a multiple of 6, I want the first equation to start with 6x and my second equation to start with negative 6x, so that when we add them together, they cancel. So in this first equation, in order to take that 2x and make it a 6x, we need to multiply by 3. And I'm going to multiply that 3 by each and every component of the equation. So 3 times 2x is my 6x, plus 3 times 7y, which is 21y, equals 3 times 4, which is 12. Now make sure that you're multiplying each component by that, we call it a scalar. Alright, so in our second equation, we want to turn that 3x into a negative 6x. So I'm going to multiply by negative 2. And negative 2 times 3x is this negative 6x. Negative 2 times the 5y is negative 10y. And negative 2 times negative 5 equals positive 10. So now that I've multiplied both equations by a scalar, I'm going to add them together. So 6x plus negative 6x cancels. 21y plus negative 10y is 11y. and 12 plus 10 is 22. So I've eliminated my x. I'm going to divide both sides by 11, and we notice that y equals 2. So in my answer, the y-coordinate for my ordered pair is 2. Last step is to go back and pick one of my equations. I'm going to pick the first one and plug in 2 for y and solve. And x equals -5. So in my solution, the x-coordinate is -5 and the y is 2. On to our final example. If we take a look at this system of equations, the first thing we need to do is figure out, do any of our variables eliminate? So I'm going to start with looking at my x's. And I notice that 4x and -4x are opposites, which means I can move on to adding my equations together. 4x plus -4x is 0. Now I'm going to add my y terms. -6y plus 6y is also 0. And 6 plus 2 is 8. So simplifying, 0 equals 8. What I want you to notice is that both variables canceled out. And we ended up with this statement that is false. And if that statement is false, that means we have no solution and the system is inconsistent. Take this for example. Alright, so first we need to figure out opposites. We need opposites. So in the x terms, notice that 4x and 2x do not make 0. But if I multiply the top equation by -2, I get -4x plus 6y equals -30. So I've rewritten my first equation to create opposites for x's. So now when I take that second equation and add it to my first revised equation, 4x and -4 cancel. I get 0. -6y and 6y cancel. I get 0. And 30 and -30 cancel. So I get 0 equals 0. If everything drops out and you get a true statement, it means that the system is consistent and there are many solutions, which also means that it's dependent. Alright, that concludes the second method for solving linear systems.